Hi, everyone. Welcome back to the React Meetup Online, presented by This.Labs Media. Today's sponsors is This.Labs, your partner in digital transformation. Today, I have a couple of announcements. Besides having the React Meetup, we have the View Online, right? That is going to be taking place on May 21st at 12:30 p.m. PDT time and 3:30 Standard Day time. Also, our next Angular Online Meetup is going to be taking place on June 4th, and the next React Meetup is going to be taking place on June 11th. Today, we have an awesome speaker. I'm super excited about this talk. The speaker for today is Brian. He's a software engineer at Facebook, and he's part of the core team for React. So, I mean, this is a great opportunity for everyone to ask any questions that you have. So yeah, let's give some space for Brian. So thank you, Brian, for being here.
Yeah, thanks for having. I'm happy to hang out and hopefully answer some questions. Before we get started, I just wanted to take a minute to let everyone know sort of what the React team has been working on. As you might have read online recently, we are using React's experimental concurrent mode in production on the new facebook.com website. We're excited about the new features, and we've learned a lot of things from supporting the engineers and product teams who worked on the Facebook rewrite. So now we're working on getting a stable release for the open source community to start using it too. And we want to make sure that the upgrade path is as easy as possible. So Facebook has built up a lot of infra to help maintain and monitor our software. Some of this infra has been released and adopted in the open source world, but not all of it. So some of the remaining work that we're trying to wrap up before we launch the stable has to do with figuring out any gaps between the new APIs that might exist for teams that don't have Facebook's infra to help with their development. So happy now to answer some questions. And if I don't know the answer to any of these questions, I will follow up with you on Twitter or somewhere else after this meetup.
Cool. So the dynamic for today's meetup is going to be the following way. I have already a few questions for Brian for him to answer. And you can, for whatever explanation he gives to the answers that I have, to the questions that I have, you can ask questions related to that on the comments. And after I'm done with all the questions that I have, you can come up with your own questions that you have for him. So let's begin. So the first question that I have for you is, how do you use Redux properly in React? And the reason is that I'm asking this is because I have seen a lot of confusion in the community that sometimes they are using Redux for everything, right? And especially whenever they want to pass data between sibling components or like nested down components. So what can you tell me about that?
I see. So I think I would defer to the Redux documentation for usage questions about Redux. To be honest, I've only used Redux on 1 or 2 occasions, and it's been 4 or 5 years since I last used it. I know Mark Erickson maintains a repository on GitHub called React Redux Links that covers stuff from the project structure he recommends to comparisons between frameworks to getting started tutorials. So I'd probably start there.
Awesome. So let's see if anyone has any question related to that. Someone wants to send me the questions in the chat. I'll post them in a little while. Just give me a second. Then next question that I have is the context API versus Redux.
Okay. So I'm not sure if I'm interpreting this question the right way, but I'll take a stab at it. The React team has never suggested that people need to use Redux or any other state management library. And I think we stand by this. There's people who enjoy using it, which is great. But I think we want to be clear that it's not something you need to learn to use React. It's not a prerequisite. React state and context APIs are pretty powerful out of the box. The React DevTools extension, for example, the one that runs in your browser, is built using only these APIs, and it does a lot of advanced things. So I think maybe putting this another way, our position would be, if you want to use Redux or any other state management solution, that's great. Just make sure that you have a specific reason for doing it. So I think actually this maybe ties back into your first question a little bit more. Just to be more explicit, we think that the built-in solutions, just React component state, props, context, are good for a lot of things. in some apps, everything. So we want to encourage people to not reach for Redux as something that they have to use with their apps, and not to pick on Redux specifically. This was just the question here, but any external framework. We would suggest starting with the built-in APIs. And then if you notice a specific need that they don't solve, that you think some external solution would solve, that's great.
Wow, that's awesome. That's a really cool answer. And the next one is, I have seen some people getting confused with HOCs, right? So the next question is, what are HOCs? In this case, are higher order components, and how do you use them?
Right. So higher order components, sometimes called HOCs, is a pattern for sharing common functionality between components. A long time ago, we had an API called a create class for creating components. And that API had a concept of mixins that served a similar purpose. But as ES6 adoption grew and class components began replacing create class, then this higher order component pattern emerged to take the place of mixins. Essentially, a higher order component is a function that accepts a component as a parameter and returns a new component that wraps the one that you passed in. The wrapper component implements some shared behavior, some reusable behavior, and it shares it with the component you passed in using props. So for example, maybe the wrapper component subscribes to a data source on mount and automatically re-renders your component with a new data prop anytime the source changes. So just like higher order components replace mixins, though, I think that custom hooks are in the process of replacing higher order components now. So I think using custom hooks for sharing code is more intuitive. And it can be more efficient too, because it reduces a lot of unnecessary wrapper components and all of the sort of processing and memory that those components require. And I think it also makes applications easier to browse and explore with the React DevTools, although you can also use the component filters for that. But there's a section of our docs called Building Your Own Hooks. If you're curious to read more about this, I'd suggest it. And then there's also a section called Higher Order Components that sort of shows some example uses of that pattern if you're using class components and not using hooks yet.
Cool. So now the next question is, what is the future for server-side rendering in React?
Cool. So at Facebook, on the new Facebook website, we use Relay, which has a compiler that processes each component's data dependencies and generates efficient GraphQL queries for fetching the data. Relay also has some advanced concepts like data-driven dependencies, or 3D, that coordinate server and client efforts so that we don't have to download unused JavaScript on the client. But in the non-Facebook world, I think Relay adoption is much smaller. So we've been thinking about a way to approach this for non-Relay users. And we don't have a name for it yet, but we're working on an API design with a few goals in mind. So first, we want to minimize the data and code the client has to download, especially if the code doesn't get used. So maybe you have some code that's only used in a specific experiment, or maybe it's conditionally used based on a user's data, whatever that is. We want to minimize that. To help with this, we want to do more work on the server. So specifically things like fetching data and localizing components. And then we also want this new API to have minimal boilerplate, so it's easy for you to sort of start small and scale up without any major refactors. So there's a couple of ways that we've been thinking about how this API might work, but I think they share some things in common. One of those is that they distinguish between server components that run on the server and components that run on the client. So this is done to help keep the data fetching on the server, so that we can eliminate what we call waterfalls on the client. What I mean by a waterfall is when a component lazily loads data, and then it renders another component, and that component lazily loads data, and so forth. If you do this in the browser where data loading takes a while, the overall experience isn't great. So using this new API that we're designing, React components running on the server can still handle fetching data using suspense. Our thinking is that waterfalls on the server are generally okay because there's much lower latency between the server and the data sources typically. And then the server will send some kind of compact payload to the client that contains the rendered content as well as references to the code or the components that need to be downloaded to make the content interactive. And then parts of your React application that are purely static, the client might not need to download any code at all. Or if you have some components that are only used in some cases that don't happen to be used in a particular render, those wouldn't need to be downloaded either. So hopefully we will share more about this over the next couple of months. I think right now we're in sort of what's an RFC phase, essentially within the team, people submitting ideas for how this might work, trying to figure out the one that sort of checks all the boxes with the most ergonomic API, but more soon.
Awesome, cool, thank you so much. So the next one is Fragments versus HOCs, higher order components.
Okay. So I'm not sure if I understand this question, so I apologize if my answer isn't what you're looking for. But so since we talked about higher order components a few minutes ago, HOCs are just a way of writing code to make it easier to share common functionality between components. And there are other patterns for this too, like custom hooks. Fragments are different. Fragments are for enabling a React component to return multiple children. So the example our docs show for fragments is a columns component that needs to return multiple column elements for an HTML table. In that case, this component could return an array of columns, but arrays are a little more cumbersome to work with. They require each element to have a key attribute, and their syntax looks a little more JavaScripty and a little less like HTML, which makes the JSX flow a little more difficult to read at a glance. So instead, the columns component can return all of its columns wrapped in a fragment. A fragment is just a special type of component that's built into React that doesn't commit anything to the DOM or to the native app or whichever platform you're using. It's just a container to pass around children more easily. And you can use fragments as either importing the word fragment directly, or if you have the right plugin, which most of the common tools already support, you can just use two brackets that are connected directly.
Cool, thank you. Now the next one, this one is from me. I'm very interested on this one because I'm coming from an Angular side. So how would you scale a React application in the enterprise world?
Yeah, I think my response to this would overlap a bit with the answer I gave a minute or two ago about the future of server rendering, because I think that's a big part of it. We've been adding primitives to React for a while now. So APIs like concurrent mode and suspense and the new suspense list, all to make it possible to write large-scale React applications that can then be broken into smaller chunks and loaded in pieces or maybe loaded lazily. Beyond what I've already said about server rendering, which I think is the big chunk of this, I'd actually suggest the recent Facebook engineering blog post about the new Facebook.com. It's written by a couple of Facebook engineers that worked on the redesign, and it mentions a lot of the techniques and tools that we have at Facebook to use React at a large scale. It's on the Facebook engineering blog, so I'm gonna say the link right now, but if it's too long to write down, just ping me on Twitter afterwards and I will also just tweet a link to it. But it's engineering.fb.com/web/Facebook-design. And we sort of go over in detail on that blog how we do everything from CSS to monitoring performance for regressions to, I think it's very thorough. So I would suggest that more than me. Probably it would do a better job than me rambling about it.
Cool. So the next one is, can you explain error boundaries?
Yes. So error boundaries are kind of like try-catch blocks for a React application. If a component errors while it's rendering or inside of one of the React lifecycle methods, React will catch the error and pass the error along to the nearest error boundary above it. And then it lets that error boundary decide how to re-render. So generally, an error boundary will re-render some sort of fallback UI or something that explains to the user that an error happened and tells them what they need to do next. This makes for a nicer experience than if the app just stopped rendering in the middle of the page, or if part of the page was blank or non-interactive, which I think is what we used to have. Concretely, to create an error boundary, you just need to define a single static method called getDerivedStateFromError. And this method takes an error, and then it's responsible for returning a state object. So if a child component errors during rendering, React will catch the error, pass it to this method, and then it'll re-render your error boundary component with the newly updated state, and the render method can decide what to do next. And then we also, error boundaries also have a second optional method called componentDidCatch, which you can use if you'd like to log information about the error somewhere like a backend server for you to look at later. This method gets the error that was thrown, as well as a component stack string that defines sort of where in the application the component through the error was. So it might say like app header nav link, for example. And then when you're logging, you can know that that's where in your application the error happened. And using this information can be really helpful when you're monitoring a big app to see if there's a component that tends to error a lot for certain users, and then you'll know sort of where to dive in.
Cool. Awesome. So the next question comes from me as well. I came up with this one. It's a little bit broad, so feel free to answer it however you want. And the question is, where do you see React in the next 5 years?
Okay. So React currently lets you create very responsive client-side interactions, but we've seen that React apps tend to download a lot of application code. By comparison, if we don't ship any code to the client, so let's say a traditional Ruby or PHP app, we can make it load much faster, but every interaction becomes slow then because it needs to wait on a round trip to the server. So what we'd like to do is make it easier to balance these approaches. We want to make it easy to move components between the client and the server so that you can keep fast interactions where it matters, but you can also download much less code on the client. And we'd like to think that in 5 years, more apps would be able to treat server and client as a sort of continuum rather than two opposite approaches. And this ties in as well to the server rendering stuff I mentioned a few minutes ago.
Cool, very cool. And then the next one is, if you could change anything about React, what would it be? If you had the power to just, flip things around, whatever it is.
Yeah. I think my answer to this question as somebody who works on React rather than with React is probably going to be different than what you're thinking about. If I could change one thing, it would probably just be to move our timeline along faster, both in terms of deprecating and dropping legacy APIs, and even more importantly, finishing and releasing new APIs. Because I think we're working on a lot of really exciting things. And over the next few months, we'll hopefully be releasing a lot of them too. But it feels like it's really slow going. Some of these things we've been working on for years, for the entire time I've been on the team, or even in some cases longer. So I think the one thing I would change would just be to jump a little bit in the future.
Cool. The last questions that we have from the community, then I'm going to jump into the questions from the chat.
Sure.
This is the last question. How does Facebook profile React concurrent mode? And are there any missing features from the current tooling that you think makes this more difficult?
Yeah, so Facebook has some pretty advanced infra for monitoring the performance of our website. But since the new Facebook was built with bleeding edge APIs, some of our performance tooling is still catching up. For example, when running in the experimental concurrent mode, React batches and prioritizes updates, which can make it a little harder to tell why a given component is rendering at any point in time. So what schedule this component to render and why. And you want to be able to answer these questions quickly when you're debugging a problem or trying to optimize a component. So we have some new tooling planned for this. If you follow me on Twitter, you might remember me posting some prototypes of a new profiler back in December. The idea behind a new tool like this would be to show at a glance what React priorities are being worked on concurrently and how they're related. So what scheduled this work, or what's maybe blocking a given priority. For example, we're working on some low priority stuff now. Why? Is it because the higher priority render is waiting for IO to come back? Things like that. So I think this is kind of like when browsers added async call stack support. So you could look back and see what code's called a set timeout, for example. That's how I think of the new types of profiling tools that we're planning. And we're talking with browser vendors about these tools too, at least via Chrome and Firefox teams, because I think that this tooling will be helpful to other frameworks as well. Anyone who uses the new experimental scheduling APIs, for example, that the React and Chrome team have been working on. So if you'd like to learn more about this, I would say message me on Twitter and I can link you to either some prototype code that I've posted to GitHub or some videos or demos that I put together back in December. I'm hoping that we will either find time directly or since we're a tiny team that we'll be able to recruit a few people to help with the profiler tooling in the next couple of months.
Cool, very cool. Thank you so much. So now we're going to jump into the questions that we have in the chat. I'm going to start with the question from Brian, and this is what he says. Can you see the screen?
Yes, I can see.
What's your strategy for making your custom hooks in a way that is reusable and composable?
What's your strategy for making custom hooks in a way that's reusable and composable? I think custom hooks can do so many things that this is a bit of a broad question. I will say that there are certain patterns that that maybe make it harder for custom hooks to be composed. For example, one pattern would be to return an object of keys values and then spreading that object onto a component. So for instance, some custom hooks I've seen might return a bag of attributes that contains like event handlers and things like that, that then you just spread those onto a component. But the downside with this is that now that might override any attributes you had added. Or if you have two custom hooks and they both want to add an on-click handler, well, now they've both interfered with each other. So a pattern that might work better in that case is for the custom hook to take a ref and then in an effect do some stuff with that item. But I think general advice, I don't know if I have more specific high-level advice. I'm sorry. Maybe this is something I can think about a little bit and then tweet about later this afternoon.
Yeah, sounds good. Now we have another question from Vladislav. It says, Brian, what do you think about the best way to inject styles in React apps? Via style loader, inject inside head tag, or with link? What better in your opinion, and why?
Yeah, this is another case where, again, because I work on React more than I work with React, I don't feel the most qualified to answer this question. There's a lot of styling approaches, and they typically have trade-offs. The engineering blog, the Facebook engineering blog that I mentioned earlier, has mention of a new internal tool that Facebook created for the new Facebook website that lets you define styles in line, and then it extracts them at build time to a small set of styles that are, I don't know the right terminology for it, but the class would have a single rule in it. And so this has nice scaling properties at large scale where as you add more and more components, the amount of your CSS doesn't continue to increase linearly. It sort of rounds off as there's a lot of reused styles. And it also lets us do some nice stuff in terms of the compiling step, at least in terms of when we download the styles. I think we saw something, and this is mentioned in the blog post off of my memory. I think we saw something like I don't remember the number, but it was like a 50% reduction in the CSS or something very major like that, the downloaded payload when we switched to this new system. So this is certainly something that we've found useful. When I write the one React app that I write realistically, which is DevTools, it's sort of a special case because it doesn't download resources from a server like most apps do. So I just use Inline Styles with a mix of CSS modules as well, just because that scales well for me in terms of managing the development. Yeah.
Awesome. So the next question is from Eric. What's the React core team's view on the just born recall state management lib?
Yeah, so I'd probably say the same thing as I said for Redux here. Essentially, Recoil isn't developed or maintained by the React team, but several teams at Facebook have found it useful. So check it out if you think it fits your needs. Yeah.
Okay, sounds good. Then the next question is from Dragon. What happened to React Fire?
Oh yeah, I don't remember what code name that was for. Sorry, we have so many code names on the team, and for a long time, all of them started with F. Let me see if I can jog my memory on what React Fire code name reference, and I can tell you what the current state of it is. Sorry, this is when hold music would be fantastic if we had it. We had an internal wiki at one point where we logged all of the React code names, but of course I can't find it. I'm sorry, Dragon, could you actually just remind me what React Fire was, and then I could maybe tell you. Oh, React Fire was the notional DOM system rewrite.
So Mark Erickson, I have an answer to this. Thank you so much, Mark. And let me see. I think we have another question right here. I think it's like pretty cool. It comes from Dragon. Is React team experimenting with WebAssembly to get more perf? I don't really know what they mean with perf.
Not really. We did it a couple of years ago, and I think what we had learned at the time, and when I say we in this case, I'm meaning Sebastian, I think was the one who had looked at it. I think we'd sort of seen that WebAssembly's access to the main thread and DOM elements and stuff was so limited that you'd have to do so much serializing and back and forth through the bridge between the main page and the WASM context that it would negate any of the benefit. So I think the stance the last time we looked at it and investigated it seriously was that it didn't seem like it would add much or anything with its current capabilities, but maybe something worth keeping in mind and looking at more in the future as the sort of capabilities to interop between the two grow.
Awesome. So Vladislav, he was the one that asked the question about the styling, and he just wanted to continue the conversation a little bit. So this is what he replied. Yep, Atomic CSS. This is some open source lib generate styles in runtime.
Not open source. I don't know if I should say yet, because I don't know if there's plans to open source it or not. But no, the tool that we're using internally, and yes, thank you. Atomic CSS was the name I was spacing out on. The tool that we're using internally was custom written. I think, actually, I don't know who worked on it. I know Sebastian worked on it, but I don't know if others did as well. But I don't know what the plans are to open source it yet.
Okay. So it looks like we have 2 more questions. And the next one is from Brian. Have you tried sending React render tracing data into tracing tool like Zipkin, Lightstep, Honeycomb, etc.? What have you found in the experiment or at scale?
Yeah, so I think the answer for this, there's a few things that are kind of related to this. There is React, up until a couple of months ago, used to log data to the user timing API, which is essentially just performance mark and performance measure. And this puts sort of a flame graph into the user timings portion of the performance tab in the browser. And we use this to show sort of when we started rendering components and when we stopped. And so what this gave you was sort of nice inline context with the normal browser's flame graph tools for JavaScript and network requests and screenshots and all the built-in functionality that the browser have. And you could sort of see, oh, this chunk of JavaScript that's running was probably React, and it's related to this part of the application that's rendering. What we found is there's a couple problems with this. One of them was that performance measure was surprisingly slow. And we think that this, in part, was traced down to a Chrome bug that was recently fixed, where they were doing a lot of cloning unnecessarily when they were closing off that measurement. But we haven't actually verified that that fully fixed the performance problem, but just that it added a lot of overhead. And we noticed even the dev build is already kind of slow, but this would make it so we would never turn it on in the profiling build, for example, too much overhead. But we also noticed more conceptually that it was problematic with the, with 2 use cases. One of them is that the user timings panel, there's just one panel and everything writes to it. So if any other library or product code used the user timings API as well, the flame graph would get super funky. The nice flame graph tree would become this weird disjoint set of things that didn't connect in any meaningful way. We also noticed that with concurrent mode, where we might do some work on a part of a tree and then stop waiting on some IO and work on another part of the tree and then come back, the user timings flame information was a little bit hard to follow because it wasn't clear why we were working on a given thing. So the solution to all of these things, I believe, is for us to build some custom tooling, which I mentioned earlier. We did look into using not specifically the Honeycomb or Lightstat, but we looked into using a couple of existing tools for this. One of them was I forked the new Firefox profiling app, which is written in React, so it's easy for me to play with. And we tried loading the data in there. For example, we also talked with some folks at Chrome, although I'm forgetting who, about maybe an API that would let us load some data in more customizable ways into the, okay, sorry, my browser just minimized itself. That would let us load some data into the existing tracing visualizations. There's some niceness about that because the rendering code would match and we wouldn't have to maintain it, and maybe all the browsers could do their own things with it, and we could support them all without custom efforts. But the limitation of those tools, I think, are that they're still written with a few underlying assumptions, and that is sort of the fact that JavaScript's single-threaded, but they don't have the concept of this like cooperative scheduling that is a big part in the new React. And then they also don't show, because of that, they also don't show this concept of priority, which is another big thing in the new React, and I think also in new JavaScript frameworks going forward, because Chrome's releasing the scheduling API for other frameworks to use too. So what I think is, for the short term, my strong feeling is that we need to build custom visualizations to this in order to show how the different priorities fit together and what's blocking what. Maybe in the future, if we can find a spec that some of these tracing tools could implement that would let us do these visualizations in a reusable way, that's super great. I would like to not maintain that tool, especially because it's great if the visualizations are within the context of the network requests and the other things, the screenshots and other things the browser can do for you. And it's hard for us to rebuild all of that. But man, that's a long-winded answer. Yes, we've tried it, and we're still thinking about it.
Awesome. And then Mark has a question, and it's related to the.
So this is a follow-up about Fire. Yeah.
Yes. So what is the status of the React Fire code name, the project? And then he follow up this with this question, possibly somewhat superset, but a new event system work.
Yeah, so Fire was our code name for modernizing the React DOM renderer. I don't know the status of that entire effort off the top of my head, but I do know that one of the big focuses of it, which was the events, has been ongoing and is making good progress. Dominic specifically on the team has been working on it. And if anyone follows along, the repo has been landing some new APIs into React to enable it. I think the big takeaways are that we're moving events. So React used to add events, or I guess maybe still does, adds events at the document level in DOM, and then it delegates and passes them to children. But this has some drawbacks, especially if there are more than one instance of React DOM on the page. So the new API that Dominic's working on attaches events at the root level, the React root. So maybe this is like some container element down within the page. And this makes multiple Reacts work more nicely because each one has its own root with events and they don't interfere with each other. Also, Dominic's working on some APIs where you can create a custom, not custom is not the right word, where you create an event handler object, and it's basically an API for you to add and remove and coordinate custom events within the React system, meaning that they would play nicely within React's things like portals. They would play nicely with things like replaying events during hydration. You wouldn't have to worry about weirdnesses of behavior if you stopped an event or prevented default or anything, and maybe it behaves one way within the React tree, but another way with events that you manually attached. So it's addressing a lot of these pain points. And I would suggest if you're interested on that, ping me on Twitter and I can link you to some specific PRs where Dominic's committed recently that have some code examples of how he's thinking the new API would work. But I think it's still an ongoing thing. Like I think this is maybe his third iteration of this API. And each time we build it, we integrate with some products at Facebook, we see what works and what doesn't work, and then we refine it. So it's still ongoing.
Sounds good. And one more question is from Alexander. Is there any benefit using render props pattern comparing to custom hooks?
Yeah, so I think these are kind of different. There are some cases where you could use either one, but there are other cases where I think only one applies. So for example, a lot of virtualization libraries, like the stuff that I've worked on in the past, maybe uses render props, which is a pattern where you pass a function in as a prop, and that function returns React elements. So maybe if you had a table, you could pass in a prop that's responsible for rendering header columns and a prop that's a component responsible for rendering body columns. There's some niceties there. I did a write-up, a gist, I think, a while ago, which I don't remember the URL to, but I could, if you want to ping me on Twitter again, I can look it up. It would just take me 5 minutes. I don't want to do it right now. That discusses pros and cons. Oh, actually, I think I wrote it up as on React window on the GitHub issue. There's an issue I have for version 2 of React Window that maybe I'll finish someday that talks about the pros and cons of using the render prop pattern. But essentially, I think render props can be useful when you want to delegate how a part of the tree beneath you that's rendered, if you want to delegate how that's rendered to an external caller. Custom hooks are more powerful. They can do a lot more stuff with them. You can, I think where they overlap a little bit is that you can use a custom hook to return an element. So you could have a hook that you pass some props and then that returns a React element ready to be rendered. So in some cases you could use this as well to delegate that pattern. But I think render props are typically more used maybe for where you want to, these things are passed in dynamically, whereas custom hooks are things, I think that, I don't think I've seen custom hooks being passed in as props. I don't know how I feel about that pattern. It seems maybe weird. That's a rambling answer. I don't know if that's super helpful.
And we're pretty much running out of time, unless you have a few more minutes to answer 2 more questions, and that's it. If not, we're just gonna wrap it up, and you can contact Brian via Twitter. What do you think, Brian? You have a few more minutes?
I could stay for a couple more minutes if sure.
So the next question is from Ryan Lynch. A follow-up to the tracing question, if there's time. How do you visualize the traces of a React application in your head abstractly?
I think that the way that I visualize it in my head is kind of depends on what you mean. I guess the way that I visualize the prioritization, so like the user blocking priority versus the idle priority, like these priority lanes, is as a sequence of rows. So where each, the y-axis is sort of priority and the x-axis is time. And then in each priority lane, we would have some work being done. And that work might look like a flame graph, or it might just look like a chunk. I don't know. This can be seen in the profiler prototypes that I shared back in December that I mentioned earlier. The actual rendering of components is different because I think I change how I think of that based on the context, the question I'm trying to answer. Sometimes I think of it as a flame graph because React applications are trees. So if I'm thinking of a component, I'm thinking of it in like the the column inside the row, inside the table, inside the user profile. But because of how React actually works and renders these things, it's just iterating over them. And so sometimes I think of it as just a single component being rendered in isolation, and then that's got set aside, and then another component is being rendered. Yeah, I don't know if that visualization makes any sense. I think the profiling prototypes that I've shared are probably the best example of how I think about them.
Okay. Yeah. The next question is from Mark Erickson. Brian, what new upcoming aspect of React are you most excited about?
The server rendering stuff that I mentioned earlier. I think that's really cool.
Cool.
Yeah. That's the codename Flight, I guess, if you follow the code names.
Then the last question for today is from Dragon. What are you looking forward to break in 17.x, which is holding back the progress?
Looking forward to break. So I think that our plan for our plan for 17 is actually to have, I don't know how much we've talked about this externally, so I don't know how much I should take anything I say with a grain of salt because we refine our plans all the time. But I think that, so major releases are for breaking changes, and 17 by definition will have some of those. I think that our tentative plan is for 17 to be relatively lightweight in terms of the breaking changes. We always try to make it so that you can upgrade to the latest minor, fix warnings, and then upgrade to a major, and it's a very smooth transition. But I think that, so I think we hope to do that again for 17. But I think that the more interesting new APIs and changes and things like that are probably going to come in 18 or something after 17. And 17, I think we're trying to make as a nice anchor point so that if you want to continue running 18 and on, which will have some deprecations that might be, they might, I mean, it'll have a lot of great APIs, but it might have some deprecations that make you not want to use it. The idea or the thinking is that you could run some code in 17 or apps in 17 and some in 18, and they would not interfere with each other. So this means things like the new event system, since it won't be on the root, it won't be on the document root, but it'll be on the React root, they won't interfere with each other. Whereas if you have an app running in 16 and an app running in 18, the events would clash. So we've been thinking about things like that, like 17 as being like a pinning point for apps that you don't want to continue to upgrade that won't interfere with 18 and 19 and so forth.
Yeah. Cool. Well, thank you so much, everyone. I really want to thank Brian and Mark for everything that you guys have done for the community. And I remember a few months back, Mark sent me a link to one of his blogs that I'm actually gonna share it in the chat. And as a person like jumping into React, it answered a lot of the questions that I had related with Redux and things like that. So I just shared it. So hopefully take a look to it. It takes a few minutes and hopefully answers questions for you. And I really want to thank everyone who joined the meetup today, and just keep being awesome, keep making React a great community, and hope to see you guys soon in the next React.js meetup online that is taking place next month. Thanks, Brian.
Yep, thanks.